boy. All right, hey guys. Today we are going over independent versus dependent probability. Big words, nothing to be afraid of. Independent probability is kind of what you've been doing, what you've been used to. It's very similar to compound probability. What independent probability is an event in which the outcome isn't affected by another event. So it's usually associated with the word replaced, and we'll get into that at the next screen. But independent probability, it is compound. You will be multiplying, and you will be doing an action more than once. This will make sense here in just a little bit. Dependent probability is an event is affected by the outcome of a second event. Keywords is not replaced. Big hint here. Keywords of dependent probability is not replaced. By not replacing an item, it'll change the total number of possible outcomes, or the number on the bottom, and possibly change the amount of ways it can occur, or the top number. And we'll get more into this in 2 slides. But first, let's go ahead and go over independent probability. Here is a question, and we're going to do 4 different problems. The question says, Brianna has a bag of candies. There are 5 red, 3 blue, 4 yellow, 2 green, and 6 orange candies. What is the probability of her picking the following candies out of the bag if she picks one candy, then replaces it back in the bag before picking another? Keyword replaces. Because of this word replaces, you know for a fact that it is independent probability, and there's not going to be a whole lot that changes from one fraction to the other. So let's go ahead and get started. Number 1 says the probability of picking red, then blue. So let's look at red. Well, first of all, before we do anything, we have to figure out how many total candies there are. There are 5 red, 3 blue, 4 yellow, 2 green, and 6 orange. If we add all these numbers up, we should get a total of 20 candies. So back to number 1, the probability of picking red and then blue. Well, we know there are 5 red out of a total 20 total candies. Then blue. Okay, so I replaced the first red candy back in the bag. So there are still 20 candies in the bag. And how many of them are blue? 3. And what I'm going to do is I'm going to multiply. However, before I multiply, let me make more room here. Before I multiply, I want to simplify wherever I can. And I can simplify 5 over 20, and that is going to make 1/4. So 1/4 times, I cannot simplify 3 over 20. Gives me 1 times 3 is 3. 20 times 4, 4 times 20 is 80. I have a 3 out of 80 chance to pick red and then blue. Number 4 says green and then green. So the probability that I can select a green. There are 2 green candies in the bag of 20. And another thing, I'm only ever grabbing 1 candy at a time. This is going to be more important in the next slide, but please keep in mind you're always only grabbing 1, but there is still a 2 out of 20 chance to grab the green. And then green again. So because I've replaced the green candy that I potentially grabbed, and I put it back in the bag, there are still 2 green candies in the bag after I replace it, and there are still 20 total candies in the bag because I replaced the first one. I want to multiply these, but I can simplify both of these fractions, both to 1 over 10. And 1 times 1 is 1, 10 times 10 is 100. So the probability that I grab a green and then a green is 1 out of 100. Number 3 says yellow and then black. Probability of grabbing a yellow is 4 out of 20. I want to multiply that with the probability of grabbing a black candy. So if I read my question, I realize there are no black candies. So that is 0 out of 20. There are none in the bag. It's impossible. So I'm not even going to bother with this anymore because I know that grabbing a black candy is impossible. So the probability of grabbing a yellow and then a black, a big fat 0. Not possible. Moving on to number 4. If you want to pause it and try number 4 on your own, go ahead. But number 4 says probability of picking a blue and then an orange. So let's look at blue. There are 3 blues out of a total 20 candies in the bag. I'm going to multiply that with 6 oranges out of 20 in the bag. I've replaced everything, so all the candies are back in there the second time around. I cannot simplify 3 over 20, but I can simplify 6 over 20 to 3 over 10. 3 times 3 is 9, and 20 times 10 is 200. I can't simplify any further than that. My answer is 9 out of 200. That is independent probability. The hard one here is going to be dependent probability, which we are moving on to now. So what I did was I kept the same problem, but now I'm going to call it dependent probability. So the problem says Brianna has 1 bag of candies. There are 5 red, 3 blue, 4 yellow, 2 green, 6 orange candies. What is the probability of her picking the following candies out of the bag if she picks one candy and then does not replace it back in the bag before picking another? Big key word here is does not replace. Does not replace. That changes a lot of things here, and we're going to go over that. But that's very important. As soon as you see the words does not replace or do not replace, you know it is dependent probability. Other than that, it's the same problem. So we know there's still 20 total candies. And let's go ahead and I'll show you number 1, and I'll show you how it changes. So think about it. There's a bag of candies. What is the probability you draw a red? You haven't touched any of the candies yet. So currently in the bag, there are 5 red out of a total 20 candies. But it says you pick it and you do not replace. So blue. So we're going to pretend we actually got the red candy. We got the one we wanted. So what's the probability of me then picking a blue? Well, have I taken a blue candy out? No. So there are 3 blue candies in the bag, but earlier you picked a red candy and you took a candy out of the bag. So there are not 20 candies in the bag anymore. There are now 19 candies in the bag because you took one out. Now, a big mistake people make is they say, oh, there's 5 red candies, so that must mean I took all 5 out. And they make this number down here a 15, okay? Do not make that mistake. That is wrong. It needs to be a 19 because even though there's 5 red candies, you're only ever taking 1 out at a time. You never take more than 1 out. So after you've discovered what the second probability or fraction is, then we're ready to multiply. But before we do, we always want to simplify. 5 over 20 can be simplified to 1/4. So 1/4 times 3 over 19. 3 times 1 is 3. 4 times 19 is 76. Okay. Number 2, green and then green. So we're restarting the problem. We have all 20 candies back in the bag. What is the probability I grab a green candy? Well, there are 2 green candies out of 20 total candies, but we're pretending that we grabbed a green candy, we took it out of the bag. So how many total candies are left if I did not replace it? I took 1 out. So there are 19 candies left in the bag. Now, if you look here, it says green and then green. How many greens are left? If I took a green out and I didn't put it back, there's only 1 green left. So in this particular problem, it changed both of my numbers up top. I can simplify 2 over 20 to 1 over 10 times 1 over 19. 1 times 1 is 1. 10 times 19 is 190. Probability I grab a green and then a green is 1 over 190. Number 3 says the probability of grabbing a green then a blue. So green, my first one. There are 2 greens out of 20 total candies. And then a blue. Have I touched a blue yet? No. The first one I grabbed was green. So all the blues are still in the bag, but I did take a green one out and I did not replace it. So there are 19 total candies. Once again, always look to simplify. 2 over 20 simplifies to 1 over 10, and I can't do anything with 3 over 19. That looks like a B. 1 times 3 is 3. 10 times 19 is 190. My answer is 3 over 190. 3 out of 190. Number 4 is the same thing, okay? But there's an extra one, or there's a third option. So think about it. As you move down the line, as you take pieces of candies out of the bag, there ends up being less in the bag. If you want to attempt number 4 on your own, be my guest, go ahead, pause the video. If not, let's go move on. So green, what is the probability I grab a green for the first time? Well, I know the first time I go in the bag, there's 20 candies in the bag and 2 are green. Then what's the probability a second green? We've already talked about this. I took a green out, so there's 1 less green in the bag. I didn't take 2 out. I only always take 1 out. So if I took 1 out, how many are left in the bag? Well, if there's 2 total and I took 1 out, that makes only 1 left. And since I took a candy out, there was only 19 candies left in the bag. Now I move on to the third option. So there were 20. I took 1 out, and there was 19 left, and then I took another green out. So now my total changes again. Now there's only 18 candies left in the bag because I've already taken 2 greens out. And this time it's orange. So how many orange do I have? I've got 6. Have I taken any orange out previously? No. 6 out of 18. And now I can get my answer, but always simplify where you can. 2 over 20 is 1 over 10 times, I can't do anything with 1 over 19. It's got to stay the same. And 6 over 18 simplifies to 1 over 3. 1 times 1 times 1 is 1. And 10 times 19 times 3 is 570. You have a 1 out of 570 chance to grab a green, and then an orange. So this is the difference between independent and dependent probability. If you guys have any questions, make sure to attend your tutorials. Make sure y'all do the IXLs because they help you for the assessments. Good luck, and let us know if you have any problems. Have a good day.